Hi, I'm Phil, and today I'm going to talk about my Arduino Morse Code project. So the project is all about Morse Code, and it's going to describe a little bit about the background and the history and how Morse Code and telegraphy in general have had an impact on society. I'll also look at one of my projects, and in this project I'm going to put a Morse code encoder onto a Spitfire fighter plane. And finally, I'll give you some of my references. So this project's all about learning about Morse code, its origin, and the use of it. So Morse code is one of the techniques used in telecommunications, that is using electrical signals to which are transmitted long distances. But in this case with Morse code, we don't use voice transmissions, we use dots and dashes. And they encode the English alphabet originally, and it's now an international standard for many languages. Morse code has used to communicate with the rest of the world, and it's used in warfare, rescue, and navigation. So the techniques of using dots and dashes all depend on the timing of those signals. And the name Morse was named after the inventor, Samuel Morse, who was an American. So some of the impacts that we've seen already were in warfare to coordinate resources. An example is controlling the squadron so that Spitfire fighter planes could coordinate their attack or defense against an enemy. And the Spitfire had both radio and optical communications. For rescue, Morse code was used as the international standard for maritime distress up till 1999, where it has been replaced by an alternative system. But it's still used in radio navigational aids and in aviation. So the key encoding technique is the timing of the signal. So the dash is 3 times the duration of the dot. And there's another dot duration between the dots and the dashes. So that timing not only extends to the dots and the dashes, but also provides a space between words equal to 3 dots. And words are separated by 7 dots. And the way that Morse code was encoded was to take the most common symbol in the English language, the letter E in the alphabet, and it gave it a single dot. By doing this, there was less need to have lots of dots and dashes to use the most economical way of using the symbols. So the applications are very closely related to transportation, and Morse code provided one of the first effective railway safety systems, so that signal boxes could coordinate their movements across the line. And it also provided a means for national time. So besides having accurate watches, this method allowed reliable timetables for railways to be developed. And Morse code is used in early aviation, both for safety and also to let an airport know about the intended landings and takeoffs. So back to the inventors. The key inventor is Samuel Morse, but he also got a lot of help from physicists, Joseph Henry, and also Alfred Vail. And the interesting thing about Morse is that the actual code was developed by Alfred Vail, and Morse was more, he gave a contribution more to the use of repeaters for communicating long distances. But it was also selected by companies that wanted to minimize the cost of installation. So you needed a single wire plus a return earth. But it did evolve. And one of the issues was the Europeans were not really happy about just using the English language, and they wanted to expand that and also provide a more reliable method. So even though the code is still called Morse code, it has evolved considerably from the early days. And also, besides the code itself, there's it's the world's first texting system. And a lot of these codes start with a Q for question. And I got involved with a branch of that where you could confirm the reception of a transmission from an amateur radio station or an international shortwave radio station. So there's an example of a QSL card that was sent out. So originally the message was in Morse, and you told the person transmitting the message how good their signal was, when it happened, and the message that they transmitted. Now, Morse code and telegraphy have had quite a big impact on Australian history. And in particular, it was the first time that the squabbling colonies had to agree on a standard and a way of connecting their independent Morse code systems. But eventually, they also had to agree on methods to connect to the rest of the world. So a very good reference to this is by Kevin Livingston, who looks at the politics of Morse code and the way that it has been used to unite Australia, and the way of negotiating eventually led to the Federation of Australia. So this is what the first networks look like. And the first one actually started near Melbourne, and it evolved very rapidly. So each of the states, except Western Australia, had a contribution to the network. So internationally, Australia wanted to be connected and get the news quickly. It wasn't that long ago, prior to this, that it would take quite a number of months, 3 months, for mail to arrive in Australia. And this meant that our news from overseas was quite stale and overdue. So to connect to the rest of the world, we looked at surveying a route from South Australia to Darwin. And in 1872, our first links to the rest of the world occur. And it didn't take long after that before we established additional routes. So before the Titanic, Morse code and telegraphy were widely used and compulsory on railway systems. But the Titanic proved that the radio codes and Morse code in particular was very important in maritime safety. So the two radio operators, Jack Phillips, who perished in the sinking of the Titanic, was more familiar with a code called CQD. And that was the signal that he initially sent out. But his junior operator, Harold Bride, suggested that they start using the new international code called SOS. And here is the only picture of a radio system on the Titanic. And Harold Bride is at the desk operating. And this is what the Morse key looked like on the Titanic. So it's got a peculiar shape, and partly the shape was to a safety aid to prevent lightning strikes to the operator. So besides railways and shipping, aviation began to depend on the use of Morse code. And in particular, for warfare, Spitfire planes, which were used in the Battle of Britain, heavily depended on the use of Morse code. So the Spitfire jet was had an advantage over the German Messerschmitt planes, and that was because it had fairly good performance at high speed and also at high altitude. So they, although they started manufacturing them before the Second World War, they were one of the main fighter planes of the Allies in World War II, and they were even manufactured after World War II. But the key thing was not only just a single fighter plane, but it was how squadrons of planes worked together in a team. And to do this, they needed reliable communications. So during normal times, they could use radio, but at other times, when there was radio silence, they used an optical Morse code. And there were two of them on the Spitfire. One was a aircraft to aircraft on the top of the fuselage, just behind the cockpit. And the other one was a aircraft to ground Morse code light. So these are some of the maneuvers that they would carry out. And if they wanted to change their pre-plan, they would use the optical Morse code. So, for example, there's one of the maneuvers that they would use in the squadron. So this is what the key looked like in the middle. And on the right, you can see where the lamp, the upper lamp, was located. So for my project, I want to use that upper Morse code lamp and include it in an Arduino Morse code project. So my objectives are to type my name on a serial terminal. All the characters have to be in lowercase, and I'm going to translate my name onto Morse code. And I'm going to display it on a LCD screen. So the top line of the screen shows the name, and the bottom line shows the encoded Morse message. But I also want to display it on a LED. So to do that, I've set up the color of the LED using this dual inline switch array. And I can set up my keys. The green key is for the Morse key. The red key is for a preset message like SOS. Just press that button once and it will send out the pre-coded message in Morse. And the picture in the middle is the RGB LED, which is where the Morse code eventually is seen. So besides learning about Morse code, there's a number of other objectives. I want to use interrupts. I want to be able to read an analog reading, use arrays, find out how I can use state machines, use functions, APIs, and interface to both analog digital, but also to I2C and serial COM devices. So for the operations, initially you would set up the dual inline switch, and if you wanted a particular color on that on your LED, you select the pattern as I've shown here. Switch 1 is for red, 2 is for green, 3 is for blue, and if you want the dots and the dashes to alternate between red and blue, you turn on the fourth switch. So let's talk about the hardware. So this is what the Cedino Lotus computer looks like, and it has a number of Grove sockets, 12 of them, to communicate with analog, digital, and other devices. The Morse code eventually goes out to the LED, and that's shown on the right, and the patterns to select the color are shown on the left. Here we continue with our Grove sensors, and on the right we have the two-line liquid crystal display, and on the left we have the potentiometer. So I'm using the potentiometer here to set the speed of transmission of the Morse signal. And finally, we've got on the left the dual button array, and I'm using the red one for the preset message and the green one for my Morse code key. Alternatively, if you just wanted one, you could use the cheaper single push button device. So how is all that put together? Well, the Lotus computer combines the capability of an Arduino computer with 12 Grove sockets to connect to the Grove devices. So for the sensors or the inputs, they connect to these ports, and I just add the actuators and it makes up the complete set. Perhaps the final item is the Spitfire Morse Code communications light, and I'm going to add that to the RGB LED. So for software, everything's going to be done in the Arduino IDE, and it's based on an existing program, but I'm going to modify that for the devices that I've chosen. And it compiled and operated reasonably successfully, and it uses about a quarter, 1/3 of the RAM that I've got available. So here are some of the global variables that I'm using to identify the Morse code key, the red button for SOS messages, and the other devices that I'm using, such as the potentiometer and the nominal tick duration for a dot. In the software, I'm creating 3 objects, and each of these corresponds to one of these devices. And this helps me so that I can use other existing published libraries instead of having to do all the hard coding myself. So the functions in my program are for timing and controlling the dash, the dot, encoding the Morse from English text, and also for engaging with the switches. That is when you press a button and when you change one of the dual inline switches. And for all of these, I'm using interrupts. So in the main loop, I just check this potentiometer for the speed of transmission and check if serial comms message is to be sent, or whether I need to transmit the pre-coded message such as SOS. And the results are good. I was able to achieve all of the objectives that I initially set, including typing my name. It typed my name and gave a Morse code onto the LED. Some of the issues, I could have used an alternative way. Instead of lots of commands for the dots and the dashes, I could have encoded those using arrays instead. I wasn't able to get the LCD to do auto scrolling. So when I'm displaying a name, it works well for short names, such as my own name. But for longer messages, I lose the first characters. That's only on the LCD though. But it still works with even long messages for the encoding and the display of the Morse message. So there are plenty of extensions. One is to convert the uppercase to lowercase and add a buzzer, and also to measure the speed so that if in manual mode, it would be nice if I was able to measure the performance of the Morse code operator in words per minute. And here are my references. And references for coding within the Arduino IDE. And finally, I wanted to identify where I've taken some of the images that I've used from other websites. Okay, so thank you for listening.